This is section 4, rates of change, example 4. All right, so this example, it's going to be your favorite, right? Because everybody loves fractions. So there's going to be some manipulating of fractions. If you have a hard time with fractions, feel free to come and see me, okay? I would not like fractions to be the reason that you're not successful in this class. That would be very unfortunate. And I know people struggle with fractions, but remember I've got that little button that says I heart fractions. And it's because I do, because they're much more accurate than any kind of decimal would be as long as it's repeating. So let's go ahead and do this. The slope of the secant line is between x equals 1 and x equals 4. So just like last time, we're finding f of 4 minus f of 1 over 4 minus 1, because remember the slope of the secant line is given by the slope formula. The slope formula that we've known since we were in Algebra 1. We're taking 4 and 1 and plugging it into the equation. So we have 2 over 4 plus 1 minus 2 over 1 plus 1. All over 4 minus 1, which is 3. All right. Now, there's this thing that you're allowed to do. First, let's simplify. Okay, let's simplify first. So we end up with 2 over 5 minus 2 over 2, all over 3. When we add fractions, don't forget you have to have the same denominator. Right now we do not have the same denominator. So to make them the same, I need to multiply the top and the bottom by the thing that will make them the same. Well, if I have 5 and 2, the smallest thing you can make between 5 and 2, remember they can only get bigger, is 10. So I'd multiply the first fraction by 2 and the second fraction by 5, which would make both of my denominators 10. Now, when I do this, I get 4 over 10 minus 5 times 2 is 10 over 10. But watch what I do now. I'm going to take this 3 and I'm going to pull it out front. Okay, and the reason I can do that is because remember, when you divide by a number, you're actually multiplying by its reciprocal. And the reciprocal of 3 is 1/3. Okay, if you missed that, listen to it again. And I'm going to do it again in part B. So now I can simplify, which means I really have 1/3 times 4 over 10 minus 10 over 10, which is negative 6 over 10. And then I don't know about you, but I like simplifying fractions before I multiply them. So this 3 goes into 3 once, but 3 goes into 6 twice. So I can cancel them, and I end up with negative 2/10, which is the same as negative 1/5. Okay, so that's the slope of the secant line. The slope of the tangent line is going to take a little bit more work because we're going to end up with variables. Okay, but it's the same idea. So we're finding the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I'm going to take the x value and plug it in, so I'm really finding the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Now I'm going to take 2 plus h and 2 and plug it into my equation. So I have the limit as h approaches 0 of 2 over 2 plus h, that's a 2, plus 1. Okay, remember I'm just plugging it into the equation, minus 2 over 2 plus 1. And that's all over h. So now I have the limit as h approaches 0. Now remember how I said anytime you divide, you can actually just multiply by the reciprocal? I'm going to go ahead and do that because it's a little bit prettier, right? I don't have fractions over fractions or fractions within fractions, right? They'll just all be next to each other. So I'm going to take the h and pull it out front. This is going to be 1 over h times, and then I'm going to simplify this. So if I have 2 plus h plus 1, I actually have h plus 3. So it's going to be 2 over h plus 3 minus 2 over 3. Okay, you might notice that I'm leaving a little bit of space because I'm going to have to manipulate this equation. Now, in order for the denominators to be the same, remember, when you have a denominator that's an actual equation, You can't just add 3, or you can't just add h to make them the same. That's not how it works. You can only multiply. And so because you can only multiply, in order to make them the same, the denominator is actually going to be 3 times h plus 3, because they technically don't have anything in common because of the addition, right? Addition is the worst thing you could possibly have when you're talking about fractions. All right, they're the most complicated. So in order to make them the same, again, we're going to multiply them by each other. So I'm going to multiply the first fraction by 3, and then the second fraction by h plus 3. Now they're both 3h plus 3 in the denominator, which is what I need. I need them to be the same in order to be able to combine like terms in the numerator. So also, don't forget, this negative is going to be distributed. Okay, so watch, we're going to have the limit as h approaches 0. We still have 1 over h, that didn't change. 3 times 2 is 6. So we have 6 minus, so I distribute the 2 to the h, but it's negative 2. So it's negative 2h, and I distribute the negative 2 to the 3, so it's minus 6 over 3 times h plus 3. Now I get to cancel. So 6 minus 6 goes away. That leaves negative 2h on top. Which, so the h will, this h will actually cancel this h. So we end up with the limit as h approaches 0 of negative 2 over 3 times h plus 3. And remember, all you're doing now is taking the 0 and plugging it in for h, which doesn't give us an issue this time, or right now, okay? It just tells us that if this is 0, that's gone. So we have 3 times 3, which is 9. So the answer is negative 2 over 9. That's the slope of the tangent line. All right, now we write the equation of the tangent line. So, one more step. So we have 2. We plug 2 into the equation, which was 2 over x plus 1, which makes it 2/3. And then the m we just found was negative 2/9. Which means if the equation is y minus y1 equals m times x minus x1, we end up with y minus 2/3 equal to negative 2/9 x minus 2. And that's the answer.